Alright, ladies and gentlemen, time for some analyze box plots, kind of a short lesson here. The idea is, hopefully you know how to make box plots by now, and now we're just going to analyze them, we're going to look at some of them and be like, oh, this means this and this means this. And some of these things do require some opinions, and so hopefully you have opinions, and you'll be able to justify it based off of what you see in the box plots. For example, here, if you go to the, I believe it's on the second side of that first page there, we have these three beautiful box plots which kind of describe the distribution of the salary of these three different professions: nuclear engineer, police officer, and musician. And so you can kind of read through these statements here and figure out which ones would be true. Let's look at the first one. Median income for nuclear engineers is greater than the income for all musicians. Well, if you go to nuclear engineer median, that's the line in the middle of the box plot, is that higher than everything that's in musician distribution? And that would be no. So that one is false. B, the median income for police officers, that's this line, and musicians is the same. It looks like they are. So that one would be true, right? The median is the line in the middle of the box there. That one's true. All nuclear engineers earn more than all police officers. So you have to look at this entire plot here. Are all of those values higher than all of the police officer ones? No, because of this section right here in the middle. There's some overlap, so some nuclear engineers make less than some police officers. So that would be false. And then all musicians will eventually earn more than a police officer. And that's this, right? Eventually earn more. You can't determine that by this box plot. A box plot doesn't tell you what happens over time. It just tells you what things are at a specific time. This doesn't show you that things get greater as time progresses. It just shows you what it is right now. And so this is not a true statement based off of what's on the picture right now. It could be true if we had something like just a line graph that shows things over time, but that's not what we have. We just have a snapshot of what's right now. Okay, which of these three professions has the most variability, and how do you know? Remember, variability is how things are spread out. If something has more variability, the standard deviation would be greater, and so it's more spread out left and right. Well, the musician is quite wide as far as its box plot is concerned. There's a lot of variability between here and here. The box of the box plot is bigger than the other ones. That means the variability is bigger. The more spread out, the more variability. And so that's one right here, except use words. It'd be musician because the box of the box plot is bigger than the other ones, and the entire graph is bigger than the entire graph. For the other ones, it's wider. And so that's what you put there. And if you flip over to this part, we got your what percent of students got right on the previous math test. And you got yours class, and then your friend's class. What percent of your class got 90% or better? Well, 90% is right here. And, well, that's right at the median. And so 50% of your class got 90% or better. See, 50% of your friend's class got better than what score? Well, if you're looking for just 50%, not 100%, that'd be right there. Everything to the right of that is 50% of your friend's class. And so that would be 80% on the test there. What is the interquartile end IQR of your class and your friend's class? Well, your class goes from 85 to 95. That's a spread of 10, so yours would be 10. And then your friend's class, come on, spelling. Your friend's class, well, it goes from 70 to 90, and that's a spread of 20. If you do 90 minus 70, that gives you 20. So there you go. Let's say you and your friend had the opportunity to transfer to the same class. Would you transfer to your friend's class, or he or she transfer to your class? Well, you got to look at these and just decide what you want. Because, if you assume you want to get better scores, your class is getting better scores. If you look at it, you got more higher scores for your class. A greater percentage of your class is getting higher scores than your friends. He has more lower scores, or he or she has more lower scores. And so if you're going for better, you want to go to your class. And then you want to explain why. You want to say that 50% of yours, like everything above the median, is 50% of yours is getting from 90 to 100, whereas in your friend's class, only 25% of the class is. And if you look at yours, 75% of it from the first quartile onward is getting better than half of his by far, and even a little bit more than 50% of his or her class. And so those are sort of things, but you also would want to, everything has a context, and so if your friend's class was actually a better environment for you, that could give you some sort of other things. But yeah, so you make a decision here. You probably want to go to your class, but maybe you can think of a different reason why you want to go to your friends. But include some sort of description as to why, based off these box plots. Mention things like who has greater scores or things like that. So there you go. Kind of an idea of analyzing these box plots and stuff.